Welcome
to the joy of coding.
Hello, and welcome to episode 138 of The Joy of Coding. My name's Mike Conley, gonna be hacking on Firefox stuff today. Same as usual, nothing new. It's Firefox through and through. Hey, I made a little rhyme. That's nice. How are you? It's been a couple of weeks. I spent last week traveling, and so I could not stream. So good to have you back if you're back with me. Here's my screen so you can see what's going on. So what we're looking at right now is the agenda. The agenda is, even though this stream is is essentially unplanned, I don't really know what's going to happen. There is a kind of an agenda. I have a list of things I want to try and get to, and whether or not I get to them, we shall see. I'm just realizing now that I did not plug in my laptop, and so I'm going to run out of power because streaming takes a lot of energy. So let me just quickly find the power cable and hopefully not accidentally unplug anything and give my laptop some juice. There we go. Okay, so this agenda is something that you can click on and have access to. If you're watching this on Air Mozilla, the new Air Mozilla, it'll be in the handout section. I'm not sure where it's going to be, on the left, on the right, up above, somewhere. Just find the handout section because the link to the agenda is there. If you're watching this on old Air Mozilla somehow, even though we've shut down that site, it's in the additional links section down below. If you're watching this on YouTube, then the agenda is in the video description down below. And if you're watching this on Twitch, I'm about to drop the link in the Twitch chat right now. Agenda. There you go. The agenda. So first of all, no plan survives breakfast. This is me trying to capture software development in the raw. Trying to demonstrate what it's like to be like working on code. So it's like there's no pre-planned like solutions or I haven't like figured out how I want to do things right away. I'm just worried. If you're wondering what I'm doing, I'm worried that the audio output is just a little low. Am I loud enough? For the people who are in IRC or in Twitch, let me know if I'm not loud enough, if I'm a little quiet, and I'll do my best. I'm looking at the little VU meter here in OBS, and it looks a little low. If it's okay, let me know. That's fine, and I'll do my best to adjust it. Okay, so no plan survives breakfast. I mentioned that. It's okay if I make mistakes. I might get stuck. That's just the way things go. The second thing is that there's an episode guide, and that episode guide is driven entirely by you, my beloved viewers. So if you're not familiar with the episode guide, check it out. It is a big list of episodes here. We've got up to, I think, episode 136. And each one of these is, if you click on one, like a minor breakdown, like a little mini breakdown of the sort of stuff I cover in the episode. And you'll have a link to the episode on Air Mozilla, which hopefully will redirect to the new Air Mozilla when that launches, and then the link to the agenda. So that's handy. And hopefully we'll have an episode guide up for this episode shortly after. Now, a thing that you should know, though, is that these episode guides are completely viewer-driven. And so if you have your own episode, like notes, maybe things, corrections, maybe I made a mistake, or you have some commentary, you can actually send a pull request to the episode guide here to the repository, because it's an open source GitHub repository. These are all the episodes, and you can look at the Markdown source. And you can send me a pull request. And if you're not sure how to do that, there's a guide in the agenda on how to send a pull request, and I encourage you to do that. Lastly, okay, another James is saying, sounds good here from Twitch. Thank you, another James from Twitch, for the confirmation on sound quality. Thumbs up. I want to give one little shout out to the transcriptions that I'm doing on amara.org for all of the archived episodes of the series. There is a long tail of series. We're up to like 138 now. A lot of episodes. And so I've uploaded a bunch of them to the service called amara.org, where people, viewers just like you, can help me transcribe them. Now the good news is that a machine has already done a lot of the work. I used this script called Adzo that I wrote to use the Mozilla Deep Speech Wind Waker or Riot. So intense. I'm getting really interesting chat commentary from the Twitch folks. I think they think I'm playing Zelda Wind Waker. And so if this is what... I never played Wind Waker, so if this is what Wind Waker is like, then Zelda took a turn for the worse, I would imagine. So there is a script, not a script. Yeah, I wrote a script to do speech-to-text auto-transcription using Mozilla Deep Speech. And the transcriptions are here up on amara.org. So if you create an account on amara.org, and you can open up the spreadsheet here, look at the transcripts, and then submit corrections to the transcripts. That's what I'm asking you. I'm offering that as an opportunity if you want to help out, help the other viewers who might not necessarily be able to hear me speaking or might want to be able to watch me while there's like silence. I haven't used my sarcasm button all day. Who are all of these people? There are a ton of people. There are a ton of people in the Twitch chat just chatting at me. And apparently I haven't used my sarcasm button. How's this for a sarcasm button?
That's right. That's right.
You all?
I'm not sure why. So Princess Kill J0 says, have a good show. Thank you very much. All you folks in Twitch, not sure where you came from. Glad to have you here. I'm going to be hacking on Firefox stuff. And some people are like, I'm out. I can't handle this. All right, we'll see you later. I'm not playing a game, just so you know. This isn't me playing a video game. I'm going to be hacking on the Firefox code base. I'm going to get there, though. So before I finish going through the preamble here, I just also want to mention that there is a link to rate the episode. If you end up finishing the episode, it sounds like the people on Twitch aren't going to watch the episode. Wow, people are really upset. Send me feedback on the forum here. If this is what you came to watch, if you're watching this because you want to watch someone hack on Firefox and not play a video game on Twitch, do fill out the form and let me know what you thought. The form link here is in the agenda. There it is. Rate the episode link. Assuming playing during daytime now. That's cool. What am I? I'm not entirely certain these people are watching the same thing I'm watching. Am I? I don't know what's going off, like what's happening on Twitch. I think they think I'm playing Wind Waker. What's the song? I don't know what's happening on Twitch right now. I'm just gonna keep going. Never mind. So what are we doing today? Well, I have a couple things I want to do. First thing I want to do is I want to review some code that was sent to me by one of the other Mozillians to try and make tab switching faster. And this is called the LRU Cache. This is a thing that we've wanted to try for a little while now that Firefox 60 was released today. You should go get a copy if you haven't yet. It's really, really great. And 61, which is on beta, or will be on beta soon, has the tab warming optimization that we were working on a couple of months ago. Now we're looking at a new kind of optimization. This one's called the LRU Cache. And the way this works, I think the chat is bugged. Hang on. So I'm getting like a ton of stuff in the Twitch chat here that doesn't sound like they know what I'm doing. Just so you folks know, this stream is me hacking on Firefox and not like playing music or something. Are you seeing music? So if you're not seeing me right now working on a Firefox bug, you might be watching the wrong stream. Sorry about that. Let me just, all right, I'm gonna quickly check to see what people are seeing on Twitch because I'm very curious. I will mute it. It's muted right now. No, that looks like me. I don't know what the dealio is. I think it's just There are apparently only 5 people watching. I have a feeling that the chat room is just bugged out. Not sure what's going on. I'm just gonna keep going. Good luck, Twitch chat. I hope whatever's happening over there will eventually make sense. It's just chaos. All right. So the LRU cache, the way it works is, historically what we've been doing is, and when you switch a tab, we tell the content process that that tab belongs to, hey, paint your layers, paint all of the parts of the page, upload it to the compositor, and when you're done, let me know because I'm going to do the tab switch. And that takes a little bit of time. And the tab warming optimization we were working on a few months ago was a way of getting around that, because what we do is when we hover a tab, now we do the paint in the background. When you're hovering the tab with the mouse, we warm up the tab so that by the time you click, chances are the paint has completed, and we can switch the tab like instantaneously. And so the LRU cache is this thing that we've been thinking about that takes things a step further. Instead of warming up the tabs when you hover them, another thing we can do is just not throw away the tab layers for tabs that you've seen recently. So what Doug Thayer, the fellow who wrote this, is doing is he's adding a cache with 5 slots. And the way that will work is whenever you're looking at a tab and you switch away, we will like have this queue of previous tabs. And if the tab you're switching to, let's say you decide to switch to another tab, if the tab that you're switching to is a tab that you saw at least 5 tab switches ago, then we never threw those layers away and we can probably switch to it instantaneously. And that's actually being informed by some research we did that showed that what was the situation? Well, if you have a cache of about 10 slots, that's going to take care of the majority of tab switches, is what we realized. When we did some telemetry, did some experimentation, most tab switches occur for a tab. Like you switch to a tab that you saw at least 10 tabs, or within about 10 tab switches ago. That's what we discovered. Or about 95% of the time, when you switch a tab, you saw it at least 10 tab switches ago. So we think we can get away with 10 slots. We're starting with 5 just to experiment with it. And so he wrote some patches to do that. Those patches landed the other day after the uplift, and nightly became 62. 2 days ago it landed, and then it bounced due to some test failures. And Doug Thayer has updated his push with a couple of patches because he suspects that the tests that were failing are actually, they just need to be modified, because they're not accounting for the possibility that a paint might not occur because we never stopped painting, or we're caching the layers. So that's one of the things he did over here, is he just modified this test to turn off the tab layer cache so that the test works properly. And then for this other patch, this is the one I haven't reviewed yet. This is the one I want to look at today. He's fixing this browser_tab switch between plugins test, and I want to A, understand what that test does, and then B, understand why it was broken, and C, figure out how he's trying to fix it. So the first step when I review something like this is I want to understand what the test does. So let's take a look at the entire test in SearchFox. It's a little long. It's about 105 lines, but hopefully we'll be able to get a sense of it soon. So the first thing that's nice. We actually get a comment here that tries to tell us what it's doing. It tests that we get plugin updates when we flip between tabs that have the same plugin in the same position in the page. So if you have two, like say Flash plugins, that's very common, or was very common when this test was written. If you have 2 Flash plugins, let's say Homestar Runner and another Homestar Runner, and we have 2 tabs open at Homestar Runner, Homestar Runner usually occupied the same region of the page, and this is a test that ensures that when we switch between 2 Homestar Runner or 2 Flash tabs or 2 plugin tabs in general, that we get plugin updates. And I'm not sure what it means by plugin updates, but we'll see. So what does the test do? First of all, we make sure that the test plugin is enabled so we don't have to click to play it. Then we load 2 tabs that have the plugin inside it right here. And then we ensure that we can get the plugin. The plugins are loaded, and the plugin tab 2, because like what, I think open new foreground tab. Plugin tab 2 should be the most recently selected tab. So we should be looking at plugin tab 2 at this point. And we make sure that, yeah, plugin 2 is selected. That's true. And we check to see that the native widget is not visible. Right. That should be false. And then we make sure that plugin tab 2 that the native widget is visible. And then we select the first tab. And then we make sure that the first plugin is visible and the second one is hidden. And then we select tab 2 again. We'll make sure that tab 1 is not visible and 2 is visible again. And then we go to test tab. Now what's test tab? Is the original tab. We go back to the original tab and we make sure both are not visible. Okay, that's what the test does. It's switching between tabs that have flash in them, and then it is ensuring that the native widget for the flash plugin is being made invisible for the tabs that go into the background and vice versa. That's what's happening. So what's Doug's test doing? So first of all, let's look at the commit message. He's saying, after digging into this, I'm not entirely sure why the timing has changed such that the checks don't work immediately. So he's updating some timing stuff, it sounds like. I have a strong suspicion, though, that it's simply because our tab switch is now instant, resulting in the necessary messages just being a little bit behind. Hopefully this is an acceptable band-aid. So what's he doing? Well, first of all, he adds this. Hopefully you can read this. I'm going to maybe pump up the font a little bit. Maybe that's too much. That's a little too much. So the first thing he does is he adds this function called wait for plugin visibility. It's a little helper function. And oh, he's adding a wait for condition. Because before we weren't waiting for a condition, we were just like, interesting. What would happen is, what he's doing is he is waiting that the condition, he's waiting for the condition to become true. Now why would the timing here change? So it's using wait tab switched. Wait tab switched. Maybe that's not waiting long enough. Let's look at where wait tab switch is defined. Yeah, okay, so it's waiting for tab switch done. Native widget is visible. So this disturbs me just a little bit, not too much, but like I want to. It doesn't disturb me so much, but I want to understand more about why. Oh, not implemented. Native widget is visible on Windows. Wait a second. Native widget is visible. It's defined for Windows only. So is this test only run on Windows, browser, tab switch between plugins? Yeah, it is skipped if it's not Windows. So only Windows gets this stuff. That's good to know. And the way it works is we get the object, we do this. This is the actual check of some visible plugin native widget is visible on Windows. We're waiting until this returns true. Now, is there a thing that like widget is visible. When was this added? It's added by Rock. Jim and Rock added this test way back in the day. Native widget is visible on Windows. Works in eTennis. Now it's useful in testing eTennis related compositor plugin window functionality. Civil window class. And what was this doing? This blocks here, where 3 years ago Jim fixed a bug where compositor, we update the plugin window state. So if the compositor is keeping the layers, it would make sense. I'm actually curious about what's clearing the plugin window state. If we're keeping the layers, update plugin window state. What calls that? Async composition manager. Resolve plugins. And that happens inside resolve ref layers. And that's inside auto resolve ref layers, which happens whenever we notify or we composite or we update the shadow layers. Our transaction pair, we receive an update. Manage layer tree for a single browser. The browser can be top level browser, which is the P layer tree. The browser can also be a content tab, in which gets the P layers and the content browser. Now, the P layer parent exists in the GPU process. So if the GPU gets an update, then we resolve the ref layers, and one of the things we do is we go through each of the ref layers, find the plugin, and we update the plugin window state. So I'm a little wary. I'm a little wary of this. I have strong suspicions because our task is now instant, resulting in the necessary messages just being a little bit behind. And the necessary messages just being a little bit behind. So this is, I am worried about this. So let me write this out. This worries me a little bit. Are we saying something about this seems off? We're keeping the layers around, presumably, for these test tabs. We're keeping the layers around, presumably, for these test tabs. At some point, I guess the compositor receives some kind of signal to update plugin windows. Plugin windows here. And that's the point at which when we update the plugin window state, that's the point where we why did I think we needed to do this? Data equals false. Why did I get here? Because why? Because of this attachment should hide plugin, update plugin window state. It was because of this patch. So at some point there's like this should hide plugin thing maybe, or did that has that been factored out? I think it's been factored out. Let's go forward. Forward in time. Update plugin window state. Send hide all plugins. Hide all. Send update plugin configuration. Now what, like, is there a hiding one? I'm trying to figure out where we would hide it. Plugin windows hidden false. Plugin metrics changed to. But now or not, we need to force plugin windows. Plugin windows hidden false. Plugin metrics changed true. This is if we decide to hide all of the plugins. So let's see how that works. And then this one's called send update plugin configurations. So somewhere there's a receive hide all plugins. So here's the API. Hide all plugins, capture all plugins. Update plugin configuration. Managing plugin widgets. So somewhere there's also a receive. What would we do? Update registered plugin window visibility. That sounds like it. And so inside receive update plugin configurations. We might change the visibility. We receive update plugin configurations. That's so say update the plugin windows here, and that I guess sends a message to the parent process to update plugin visibility over here. Permalink. take a deep dive here. Oh. Update registered plugin window visibility. That we didn't need to update need to be hidden. Parent visible plugin IDs. Hang on. Maybe this is what I should have permalinked. .464. Yeah, this is a long comment, but this will be worth it. Update plugin window visibility. Let's see how that works. Base widget. And what we'll do is we say widget. If possible, say show. Not widget destroyed. If plugin IDs contains window ID, a plugin IDs, window ID, iter key. We're iterating the plugin widget list. And if the plugin IDs that we pass, if we iterate all of the plugin widgets and the plugin IDs that we pass don't contain that, then it should hide it. That's what's going on. Puppet widget, plugin instance owner, plugin frame. Okay. Which I guess sets visibility to false here for the plugins that don't belong, that shouldn't be visible. So I guess my question is, what exactly has changed in the message ordering and how? The compositor should know, I think, that the tab moving into the background is being made not visible, and shouldn't that, and I feel, and that tab, that movement and should that not occur after the tab switch done event fires in the parent process? Well, let's see how that works. So you tab switch away, we say we're clearing the layers. Should that not? We clear the layers. We don't clear the layers. We don't clear the layers. We keep the layers around. Hang on, I need to look at how Doug's patches work again. Cached. So we're going to end up switching to a new tab and firing tab switch done. So I guess what happens here is that we complete the tab switch to the new tab, even though the old one's layers are still on the compositor because it's cached. And then async tab switcher fires tab switch done, the tab switch done event, because the tab switch was fires a tab switch done event, which causes our test here to proceed. And I guess maybe there's a race now where the message to the content process to ask about the how does that even work? Because we're asking the content process if the native widget is visible. Widget is visible. Native. And then in the parent process case, what do we do? Or we are legit calling the Gecko plugin window. I guess we somehow are able to do this even though we're in the content process. All right. Message the content process to ask about the visible state of the plugin, and the message from the compositor to the parent, child, somebody, plugin, or child, or plugin, or plugin process. This part is really fuzzy for me. For the compositor to the parent or content process or plugin process to update the visibility state of the plugin. So I guess this test tab. Yeah, sends a message to the parent process to update plugin visibility. Visible, so that's just because cache, then the async tab switcher fires the tab switch done event, which causes our test here to proceed. And I guess maybe there's a race now where the message to the content process, the content spawn task, message the content process to ask about the visible state of the plugin, and the message from the compositor to the parent or the content process to the plugin process to update visibility state of the plugin. What's the right way to do this? So Push done. Instead of waiting for the arbitrary 200 milliseconds, can we instead wait for some kind of signal, wait for a message from the compositor that we know must fire after the update, the plugin visibility message goes out? Moz after paint, maybe. You might want to double check with if that turns out to be a quagmire. This Band-Aid might be okay, but I'm far less confident reviewing, making a call here than, but I'm not far less. I'm a bit less confident I'm the right person to make that call for this particular test. Jim might be the better person to ask to sign off on it. My only fear, ultimately, is that we're introducing a case where plugins might continue to be displayed over top of plugins from background tabs that we're switching from might continue to be displayed over top of the foreground tab, even if it's just for a few milliseconds. So I'm biasing mostly because I think we should ask Jim about what to do here, or maybe we can just wait for Moz after paint. At the very least, I don't think I'm the right person to review this test. Or clearing, I'm not gonna RMIS, clearing review R question mark. A person to make the final call on how to fix this test. Okay. So, that's the review. Done. Did the review. Now, why is that? Yeah, did the review. Here it is. Here's a link to the review I did, if you want to see it. If you want to link to it. It's more of like a little dive into like our plugin visibility code. So what else did I want to do today? Well, there's this really weird performance issue that is related, I think, to something we were looking at 2 weeks ago regarding the Scrollbar binding. I'm not sure if we looked at that in the previous episode. Was it this one? No, I don't think we did look at it, so we can talk about it now. It's like it's brand new. So, I don't know if you know this, but there's currently this effort underway to stop using an older technology called XBL to define the widget tree that the browser uses. So almost every piece of UI historically has, not every, but most parts of the UI have been designed and implemented using this technology called XBL. It's a bit like web components from the mid-2000s. And if you're curious about what that looks like, check it out. It's basically like define some DOM using XML and then use also XML to write script and like set properties and basically define things that you can put into Zool documents. So for example, here we're defining a node called tabbox, a binding called tabbox, and it has properties like tabs and tab panels, and then elsewhere you can see tabbox being used like in Zool documents like this, and that's how that works. And we're trying to move away from XBL because it's funky, it's weird, it's old, and it slows us down. It's an untested, poorly understood code path. And we couldn't remove it because old school add-ons relied on it, and now that old school add-ons are no longer a thing, we feel quite comfortable getting rid of it. So there's this effort called DXBL DXBL, or war on XBL. That's this bug here. There are a lot of open bugs, and a bunch of them have been closed. And there's also this website, arewexblstill.com, that measures how we're doing. Currently, we started with 300 bindings. There are now only 195 bindings remaining. We're folding bindings together, we're simplifying them, and then we're just removing them from the tree. So this is a graph. I'm going to show you some graphs real quick here. Over time, since the beginning of the effort, which was late 2017, there's been steady decline, pretty steady decline in the lines of XBL and the number of bindings. We're down to about a third of what we started with, which is great. There's a nice big drop here. I think that's when we tab browser was moved off of the XBL technology. And so, yeah, the number of XBL bindings, nice and steady. And one of the bindings that we've tried to remove is this binding called Scrollbar. And we did remove it back in the day, in just not that long ago, a couple weeks ago. 1431246, we moved the definition from XBL of how scroll bars work. We moved it into native code instead, so that in our native code, let me find you some C++ here, we create the anonymous content in C++. This is, I believe, temporary until we can finally get rid of Zool, where we don't need to do this anymore. But for now, first step is to get rid of XBL before we can get rid of Zool. So we moved the scroll bar binding, we got rid of it, and all of the anonymous content stuff was put into native code instead. And that's great, except that it caused a CP startup regression, Talos regression. So we run these performance benchmarks called Talos. They measure a bunch of different things, and the CP startup Talos test measures how long it takes to go from opening a tab to having that tab start a content process and start to process the web, the link that the tab was asked to view. So it's basically measuring time to start a content process whenever the parent is requesting that a new one be created. Like the time to start the process and get to the point where it's like loading stuff off of the network. That's what CP startup tests. And whenever we remove the scroll bar binding, for some reason the CP startup test regressed, and we weren't sure why. And so what we ended up doing is, in order to keep the scroll bar binding from re-landing and having to back us out, is we landed an empty binding. We found out that it didn't have to be the scroll bar binding. Any empty binding will do. If this is the workaround, I'll show you right now. We just put in this empty binding definition. The binding contains nothing, and then all of the scroll bars have this empty binding associated with them. It's this real wasteful, strange thing, and that allows us to avoid the CP startup Talos regression. And so Tim Dream, the fellow who was working on this project to remove the scroll bar binding, he's been looking at this, trying to figure out what is the deal. We want to get rid of this empty binding, but if we do that, then we get the 6 to 8% CP startup regression on Linux, only on Linux. And what the heck? Why is that? And so he's been doing a little bit of research, and where's the bug? Right. So this is the bug to actually remove the empty binding and investigate that the performance gain that it causes. So it's less of the performance gain and more about why is removing that binding slowing us down? And so he's done a bunch of really heroic investigation. And I'm going to fast forward a little bit to this comment from 17 hours ago. So this is a brief overview. I'm going to read what he wrote. That's not just for your benefit, but it's for mine as well. I want to kind of swap in the stuff that he was saying to get my head into the headspace. Here we go. Here's a brief intro on what happened and what I found. Over at bug 1456728, I was flagged by Talos for slowing down content process startup by moving the Zool scrollbar markup from the XBL binding into native code and a scrollbar frame. Investigation shows that simply by adding an empty binding back to Zool scrollbar, the performance regression goes away. Given the merge schedule, I checked in the empty binding to central and continue the investigation over here. So far, so good. My methodology of locating the cause involved identifying the code path that loads the empty binding and inserting early returns in various places. So he's not really familiar with like the deep gecko stuff and is just like kind of trying to bisect his way down to trying to figure out which part is involved here, which part of loading the empty binding is causing us to perform better, it seems. By comparing the Talos results on the try pushes, I was able to narrow down the exact function calls that lead to the effect. Eventually, I reached comment 16, which skipped XML parse in NS expat driver parse buffer. So if you skip parsing the XML for the empty binding, then you get the regression back. So just parsing the empty binding, the XML parsing, not even like running the JavaScript, but just parsing the XML of the definition causes us to speed up. And if we don't parse the XML, then we regress. He says, this is very mind-blowing because XPath should be self-contained and perhaps stateless. We were hoping to find something that gets initialized earlier / later because of the binding and perhaps keeping the performance by moving it somewhere else. That's something certainly shouldn't be attempting to parse an XML file. Okay. M. Connolly had a brief discussion with me on this over IC. He recommends I use the Linux perf tool to figure out what slows us down when we don't call into XPath. It would also help us understand if the cause here is memory allocation related. This is way out of my field of expertise, so it would take some time to set it up. If you have free cycles to dive into this mystery, feel free to take over. He's ruled out NS XML document sync calls from NS parse or resume parse, but he doesn't rule out calls by NS expat driver. So there's let's start by creating a note here. For investigation. Creating a note, and I will put a link to this note in the agenda. One of the things that we did was we made the Talos test load the target over HTTP rather than Chrome. So what do we want to do here? Well, let's take a look at some of the try jobs that he did. These are Tim's try jobs, and let's see what he was up to. Remove the empty binding and make... So I don't think you can see this very well. 212, this is the CP startup score. 212, 210. It's pretty stable. It's in the mid 210s. And if we put the binding back, then this is the good score. 197, 198, 196. That's the score we want to hit, but without the binding. And so removing the empty binding causes us to increase by like 20 milliseconds or so. And then he started to print over here. He was trying to comment stuff out. And then here, whenever we don't use XML parse, this is when we get back to our regression. And the way this patch works, excuse me, what he's doing is inside this push sync stream in the sync load service, he gets the URL for some channel, gets the spec for it, and then if we're not in the parent process, we log a message, and then we check to see if we're loading the general binding. And if the URL matches, we say URL matches. Okay, so that he was instrumenting a bunch of stuff to see whether or not we're loading general.xml in various places, it looks like. Okay. So just logging. And then down here inside this function, parse buffer. So we've already read stuff off of the disk, and what's happening is on parse buffer, he says line 890. Okay, yeah, the line that he's on. If same URI, if blocked or interrupted, should not reach here. And here's where he turns off XML parse. So when he doesn't parse stuff, like when he skips this, status becomes, I don't know, the default state of XML status. And so if we don't parse, then what? What calls parse buffer? Consume token. And if consumed is greater than 0, so consumed is like the signal that comes out, and consumed should be parser bytes consumed. If it's the same URI, which is true if we skip this, then it's parser bytes before plus length size of chart 16T. Oh, I see. So he's like faking that we loaded it by saying we consumed it. Parser bytes before. I think. Parser bytes before. Or get current byte index. And then the length that we're supposed to read in times the size of 16 characters. Right. So we're saying that we did consume it. Otherwise, we just return the current byte index because we did consume it. So we're faking that we consumed it. So he's trying to make it so that any sort of side effects of having actually consumed it should still occur. Advanced, consumed. The length of the last line that xpat has parsed. Get current column number. So append the consumed data. Huh. So something about calling XML parse. He seems to think that that's what's causing us to speed up or slow down. So what's the definition of XML parse? Expat config Moz XML parse here. What is this? PS parsing is parser M, parsing status, parsing. Okay. So let's assume that it's parsing. If data are left over from the last buffer and we now know that these data are the file chunk, we have to check them again to detect errors based on that fact. If data are left over from the last buffer, begin Mozilla change, result, end Mozilla change. And XML update position. Malloc, realloc, temp. And we mem copy. Okay, so here's what I'm thinking. I want to use perf on Linux to see whether or not, like, see what the difference is between the good case and the bad case. I'm trying to figure out how best to do that. I've only got, like, say 23 minutes. Let me just check my calendar here. I gotta end the stream soon because I have a meeting right after this. So 1 second, 1 moment. 1 moment, please. Well, I check the calendar. 3:30. Okay, so I've got a little bit of time. All right, or 3:15. Got about an hour. I'm all right. I'm gonna try. This might break the stream. For the folks who are watching live stream, I am going to try and sign into the Mozilla VPN so I can see SSH into one of our Talos machines that runs these tests. All right, so pardon me. I'm going to move this off screen so I can VPN in. Go through the rigmarole. There's quite a rigmarole here. We take security very seriously. I have to do like 8-factor auth. Gotta get my iris scanned. All sorts of stuff. 1 sec. All right. So hopefully this doesn't kill the stream. I've never tried to. I don't think I've tried to stream over while connected to the VPN before. We'll see if it likes it. Apparently I haven't dropped any frames. That's good. I still seem to be streaming. Thumbs up. So what I want to do is try and SSH into the machine. And that's another thing I don't necessarily want you to see the details of. So let me just move this off screen for a sec. 1 sec. Sorry about this. It's just all kinds of like internal networking details that I don't think I want to share with the world. I don't want to have to video edit it. Okay, hold on. Gotta get the details here. I should have had them open before. Vohio, says Joe Fish. Vohio. Is that like Ohio? I've never been. Alright, so let's try and connect to this machine. Apparently this is this might take a couple of minutes. So while we're waiting on this to connect to this machine, let us look at some other code archaeology that we can do while we're waiting. This is completely unrelated. This is more about tab switching again. I noticed, I have this bug open where I noticed that when we tab switch, we do 2 consecutive paints. Oh, I can't connect to Bugzilla when I'm connected to the VPN? You gotta be joking. Come on. Oh, that's a problem. Or maybe it's because maybe I need to restart my browser. Maybe Firefox doesn't like my VPN having existed. Being existing. So let me restart the browser. Bugzilla. There we go. And another Bugzilla. Are you serious? Why wouldn't I be able to talk to Bugzilla on the VPN? That's crazy talk. Bugzilla.mozilla.org. Yeah, I can't talk to bugzilla.mozilla.org when I'm on the VPN. That's nuts. Can I talk to beast mode? Maybe I can surf on the internet through my Linux box. Yeah, alright. Hang on. Oh, no, it worked out. There we go. It just took a little while for everything to, like, resolve. Okay, so there's this profile I gathered not that long ago where I noticed during a tab switch, these green lines represent paints, and after a tab switch, it was like paint and then another paint right after. And that doesn't make a whole lot of sense. You don't usually want to do double paints, and I realized there are 2 reasons that paints are happening. The first one is here, where we just like straight up schedule a paint to occur. I'm not sure why that's necessary. And the second one is here when we unsuppress the display port. That one I understand more. So whenever we tab switch, so we have this thing called APZ, and APZ allows us to scroll really smoothly. And the way it does that is because it doesn't rely on the content process to paint every time you scroll. Instead, we overpaint on either side, like throughout the scroll area, and then we tell the compositor to just translate the scrolling layer, and then whenever you reach the edge, then we paint more, that sort of thing. And that means that we're always just kind of like overpainting. When we tab switch, we were historically painting not just the area in the content area, but if it was especially a long page, we would paint outside of that content area because you might scroll, because we have APZ, async pan zoom is what we call it. Well, we realized we could speed up tab switching if we suppressed the painting to just the content area for a brief moment. So like you suppress the painting area, then you paint, so you just paint the area that the user needs to see, and then you unsuppress for the next paint. And that works, except what we end up with are two paints. You get like the first paint to paint just the content area that's restricted to the content area here, and then we do a second paint like immediately after to paint the area outside. And I suspect we don't need to do that. I suspect that we can unsuppress and paint on demand, maybe? Or something. I'm not sure. I want to dig into it, but that one I'm not so worried about. It's this first one where we like just unilaterally schedule a paint right here that I want to understand. And so I did a little bit of archaeology, and that scheduling was introduced back in this bug here. About 2 years ago, Bill McCloskey says, why do we need to so his reviewer, D. Vander, said, why do we need to schedule a paint before painting? Would be good to comment this, but I'm interested in the answer in the bug too. And he says, Bill goes, I'm not entirely sure. However, we don't always call press shell paint right after. Usually we call puppet widget paint, since that also does layout and some other important stuff. We don't always call press shell paint right after. Usually we call puppet widget paint. I think that routine might not paint unless we schedule. We don't always call press shell paint right after, but we call puppet widget paint. So let's see what he's talking about. Let's go inside tab child. So this is the scheduling right here, and then we do this, we have this two choices. Joe Fish is like, it's a tab, it's a Twitch remote command that shows a chibi waving hi. Oh, that's what Vohio is. Hi, chibi character. I can't see it over IRC. And he goes, dunno, but it works. Don't touch. Unfortunately, a lot of geckos like that, but we must do our best to try and understand what's happening. Gecko and Firefox, certain chunks of the code, very well understood. Other parts, especially the older parts, not as well understood, at least not by me. Like it's spread out between a whole bunch of different people. So I just got to learn it, just got to figure it out. So here's where we schedule the paint. And then we have this like choice where apparently if it's safe to run script, then we paint now on the web widget. Otherwise, we paint on the pres shell. And I think that's what he's talking about. We don't always call pres shell paint right after. So first of all, why this choice? Have I been kicked off the network again? I'm not dropping frames apparently, but I just got booted off of IRC. Network is super funny whenever I'm on the VPN. So my question is, where did this stuff come from? Like, was this always the case? And so I want to look at the patch, the original patch here. And unfortunately, being on the VPN is really hurting this cause. So you know what I'm going to do is I'm going to disconnect from the VPN. This is just hurting. This is just hurting. And I don't know why that is. I'm going to disconnect from the VPN. And now everything should just work again. There you go. So what he was doing was schedule paint. So we always had this paint now if needed thing. So let's take a look inside receive render layers and see if we can figure out where it came from. Paint now if needed. Let's look for the earliest version, latest version without that line. Schedule paint, no, paint now, paint. Set active. Receive set doc shell is active. This here. Safe to run script. So I think I went back too far. So he's the one who added is safe to run script. Safe to run script. And is safe to run script is true if safe to execute content script and false otherwise. The only known case for this lies mutation events they run. It can run anything else when this function returns false, but this is okay. And we block script whenever like DOM is doing stuff, when DOM's being maybe updated or something. Okay. So if the DOM's not being updated, then we'll do this like paint now if needed thing. And according to Bill, we do puppet widget paint in this case. Whoopsie daisy. Puppet widget paint in this case. Let's lay out some other important stuff. And I think that routine might not paint unless we schedule. And he's like, I could be wrong though. So paint now if needed is here on puppet widget. And we're like, okay, are we visible? And that will be true because we make it visible here. And so the question is there a paint task pending? And if so, paint. And paint task. And that's true if we have been called with invalidate. So if there's like a dirty region, paint now if needed. This works is how you paint the window. Widget listener paint window. Nope. View manager paint window. Fresh. Then we call paint on the pres shell. So my question is, like, I'm curious why this condition? Why would we go this way and not this way? Paint now if needed. And Bill's like, we don't always call press shell paint right after. And why not is safe. Maybe I should read through some of this. So in this bug, Bill McCloskey was making it so that we can interrupt JavaScript to paint. Melody, I appreciate somebody taking this profile. Painting usually flushes all pending style and layout changes, but those shouldn't be visible to JS. I think in JS that would query them would have forced the same flush to have happened. Painting usually flushes all pending style and layout changes. When we paint via the refresh driver, we take advantage of the paint throttling code that stops us from overproducing. Costs have multiple interrupt costs, allow the hang monitor to have its own interrupt callback that does painting. I removed the request notify layer tree array cleared methods on the frame loader that platform dollars events for remote flames is less racing silver for no remote browser. I had to fire the events manually. I removed the instrumentation. What was this? Oh yeah, that was this thing. We now allow a tab that's in the unloading state to be unloaded before it moves to unloaded. To make this possible, I had to add a bunch of sequence numbering in the platform. Mentions doc shell back. True master sends child. It's just don't get confused. We want to ask a tab to paint while the content process is busy. Use the hang monitor channel thread. This patch implements the logic. Well, it's just the usual boilerplate to add a new hang monitor message. The APAC is used to give a consistent numbering when paint messages arrive from both the hang monitor channel and from P content. Considering order of requests to paint or clear requests for tab, we're now able to get requests to paint either from the hang monitor channel or from P content. The requests go into the hang monitor end up on the main thread through the JS operation call, but the first request to hit the main thread should win. Every time the parent sends a request to paint or clear layers, it increments an epoch. The child processes these requests in order of this number. If it gets a request with an older number than the previous one it processed, it ignores it. This ensures that if the parent sends requests in this order, 1 paint, 2 clear, 3 paint, and if it request 3 is processed before request 2, 2 will never run even if it's received later. It's important that 2 shouldn't run later because it would cancel the effect of request 3. The last trace wheels install and observe the composite list for update the epoch values. Remove the request stuff of the frame loader. Haven't done it was kind of gross. Since we know exactly what we're doing, a paint for a task you can suppress the display port at that time. We write to this field inside the block. Reverse layer transfer. We need to just diagnose the for this. Calling the widget's paint routine can trigger JS. So we need to call press shell paint directly. Calling the widget's paint routine can trigger JS. Using press shell paint composite triggers an event firing, which can also run JS. So we do paint layers. What are all these different ways of painting? Paint composite. Update the layer tree and paint painted layers. This is not specified. You may still have to do it if the layer tree lost paint layer contents. layers to the window. This is only true if we've decided to schedule a paint. And then we do like paint now if needed. If root, press shall get root frame. Validate all layers, display root frame, root schedule paint. And then we do like paint now if needed. And then would that like clear the scheduling? Paint. Then we revoke the paint task. And we call paint window. So maybe the problem is that we're scheduling the paint and sometimes we enter this block. And maybe what we should do is move this in here. To do add comment about paint now if needed, not firing unless a paint has been scheduled. Now if needed. So we added this function, paint now if needed. And that was it. And schedule paint. We'll invalidate all layers for frame and we'll schedule a paint. And when do we schedule a paint? Is when we invalidate. We create the new paint task. And what calls puppet widget invalidate? Woof. Puppet widget invalidate. Puppet widget show. Then we invalidate here. When we show, if not visible, and we are now visible, we invalidate here, which happens, puppet widget show happens in make visible, I think, if there's a puppet widget, which if there isn't, then this is going to break. So I don't actually think this is necessary because we invalidate here. And invalidate will create the paint task. What's the rectangle? The bounds, the whole tab, the width and the height, the bounds of the widget. Invalidates the whole thing. And then we queue the task. I don't think the scheduling is necessary. I think we can get rid of it. So that's one thing. And then the second thing is, well, hang on, maybe I should write that down. Because I had some notes here. That first paint appears to be introduced by Bill M. in here, but I think we don't need it. He says that if it's safe to run script, then paint if paint, what is it? Paint widget if needed, or paint now if needed, will only fire if a paint is scheduled, but a paint should be scheduled because make visible calls paint widget or puppet widget show, which calls puppet widget invalidate here. Puppet widget invalidate. Puppet widget invalidate. So is there a way that we can ask if the paint task exists? Puppet widget.h paint. Anything about paint? Like needs paint? Needs paint. Puppet widget needs paint. Return m visible. So that's not true. That's like should be something that can paint. Paint now if needed. Invalidated. Dirty has dirty, or like dirty region. That's the thing one could do. You could add like an assertion that like before we paint that there are dirty regions and that a task is pending, a paint task is pending. But I think we're okay. It's this one when we unsuppress the display port where the other paint is being scheduled. And I don't know if that's really necessary. So what I'm going to do is I actually had a patch, I think. Here, let's go to this one. I think I have a patch. Was it this one? Nope. Was it? This one? Nope. And was it 115? Yeah, it was this one. So let's take a look at what we've got so far. What I'm going to do is I'm going to revert this because it's part of this patch I've got on the shelf here. I'm going to unshelve. I'm going to build it. And then what I want to do is Joe Fish asks, hey, I thought Gecko was supposed to be deprecated in the near future and substitute with a Rust alternative, Servo I guess it was called, or will it be kept around for compatibility and doing bug fixes. So that is, Gecko is not being deprecated. Gecko is being augmented. So Servo is a testing ground for like new browser technologies, like our parallel style, like what's called Stylo, parallelized style resolution system, which computes CSS using multiple threads. This is something that was developed in the Servo project. It's unique to the Servo project, or it was unique. It was like the first browser to do parallelized style computations because Rust allowed that sort of thing safely. I think Gecko had tried it like years earlier, but it like C++ just made it really, really too easy to blow our feet off. So we did it with Rust and Stylo, and then we brought over the CSS engine from Servo called Stylo and put it into Gecko. So that seems to be the pattern of like we use Stylo as this like experimental testing ground, proving ground for new web technologies, and then we bring them into Gecko. So the same thing is something called WebRender, where we developed this ability to we'll talk to the GPU using a mechanism or a system that's more akin to video games, where it's like immediate mode, where you send just like draw instructions immediately to the GPU and say like draw this, draw that, as opposed to what we've done historically, which is like this retained mode of, you know, here are some layers that I've computed, here are the textures, hold on to these textures, and then, you know, well, we still do it with textures, but for like boxes as well, we'd say we just paint these layers and just give it layers to display and move around. And apparently it turns out that we can do more things faster if we just leverage the GPU and just give it draw instructions immediately, and that's called WebRender. And you can actually turn on WebRender right now in nightly only, and there's a WebRender blog that you can follow along. It's the graphics blog, and they have the WebRender newsletters, and you can hear about that. So that's coming from the Servo engine as well, and that will land in Gecko. So no, Gecko is not being deprecated. Gecko is being augmented by Rust and Servo things. Hopefully that answers your question. So I'm going to actually put that in the notes. And I'm also going to end this episode soon because I've got a meeting coming up. So I'm going to put this WebRender and other graphics blog goodies. There you go. So updated the agenda, and now I think, how's this build doing? It's doing DOM base. So what I want to know is, can I get away with not painting? Here's the ultimate question. So I think I can try removing the scheduling in receive paint render layers. So I think I can do that. This first paint. Try getting rid of the scheduled paint when unsuppressing. So in order to do that, I have to ensure that I'm not opening us up to checkerboarding unnecessarily. So there is this thing called the minimap used by the APZ developers to and you can see it here. It will show like the painted region is actually quite large. It's that green region is the painted stuff, and the purple region is what I'm viewing, and that's how I'm able to like view things, like scroll reasonably smoothly, although the mini map itself is quite expensive. And if I ever get outside of the green region with my scrolling, then I checkerboard. And where checkerboarding is like we've not painted the region that we're looking at. And so we just display blank or something. That's called checkerboarding. So my question is, if I don't schedule that paint, what happens in the minimap? And so we will see, but I don't think I'll be able to see in this episode because this build's going to take too long and I got to get ready for my next meeting. I'll tell you what, let's give this build 15 seconds to reach the linking stage. And if it reaches the linking stage, then we'll wait for the linking to finish and we'll take a look at the minimap. But if not, then we will, then I'll end the episode. So starting a countdown now. Drum roll, if you please. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Did not reach the linking stage. So I'm going to end this episode right now. Hey, thank you so much for watching episode 100 and what was it? 138 of The Joy of Coding. I hope that was interesting. If you're interested in these bugs that I was looking at, I'm still going to be hacking on them. You can follow along by just like CCing yourself on the bug and watching the bug traffic. Let me know what you thought of this episode. So there's this form in the agenda that allows you to fill in a feedback form and let me know what you thought. I read everything that comes in, and there's a fun picture of me at the end to say thank you. I used a cool mirroring effect, and you should check that out. So check out the form and fill it in and let me know what you thought. I used it to help shape and improve the stream. So on that note, let's cap the stream. I'm just going to switch to here. And thanks again. And I will see you next week on The Joy of Coding, episode 139. We're almost at 140. And that means we're close to 150, which means we're halfway from episode 100 to 200. And that's pretty incredible. So, hey, thanks for sticking with me. And I'll see you next week. So take care. Bye-bye.
The joy of coding.
See ya.